So when we do problem solving in chemistry, we use this technique called dimensional analysis. Okay. And if we just break it down, so we use dimensions that are part of our measurements to help us solve or analyze our problems. Okay. So dimensional analysis is the technique we use to solve problems and do lots of calculations in chem. So when we do dimensional analysis, we use something called conversion factors. You do need to know what a conversion factor is. So do you see the bold lettering again? Okay. So bold is what you need to write down. Okay. So conversion factors, they're just ratios of equivalent measurements. Okay. And the key there is they have to be equivalent measurements. So here are some that hopefully you're familiar with. So like $1 is equal to 4 quarters. Or 100 pennies is equal to 10 dimes. 1,000 millimeters is equal to a meter. 1,000 grams is equal to a kilogram. Okay. And notice I wrote them a couple different ways. You can set them equal or you can write them like a fraction. Okay. So when we use conversion factors in dimensional analysis, we're going to make them look like a fraction. So we're going to take this conversion factor. So for example, 1 inch is equal to 2.54 centimeters. And we're going to make it look like a fraction. Okay, so one of those will go in the numerator, one will go in the denominator. Okay, so you could write it as like 1 inch is over like 2.54 centimeters or 2.54 centimeters over 1 inch. Okay, the key is whenever you write your conversion factor, these two numbers have to be equal to each other. All right, so then the best way to learn dimensional analysis is just to do some together. So we're going to do a handful of problems together. Okay. So let's say we want to know how many minutes are in 2.5 hours. Okay. Now some of you already have that number in your head. Okay. But we're going on the process. So step 1, you just need to have like a game plan in your head. So how are you going to actually solve this problem? And this one is easy, but are we trying to set up a nice foundation for difficult problems? Yes. Okay, we're working on your foundation right now. So we need to get from hours to minutes. What kind of conversion factor do you know that relates hours and minutes?
1 hour, 60 minutes.
Good. Okay, so we're going to use this conversion factor. 1 hour equals 60 minutes. Okay, so now I know how I'm going to convert from one unit to the next so we can do our dimensional analysis. There's a couple ways to write it. I call these boxes. I'll show you X and a line in just a second. Okay. You are always going to start with the number given in the word problem. Okay, so I give you 2.5 hours, so we're going to start there. So that goes in the top box. Put both your number and your unit. And then this bottom box, you may either leave it empty, or if empty boxes like bother you, you feel like you're forgetting something, you can put a number 1 there. Is 2.5 hours divided by 1 still 2.5 hours? Okay, so putting a 1 there doesn't change anything, it just fills the box. Okay, next we have to convert from hours to minutes, so we're going to use our conversion factor. The name of the game is canceling units. Okay, so if 1 hour is on the top box, the unit hour has to go down here. Okay, so it's got to go catty corner. So I'm going to use that conversion factor. So 1 hour goes on the bottom. And then the top has to be something equivalent to an hour. And so how many minutes are in an hour? 60. Okay. All right, so then the unit hour cancels. And what's the only unit left that doesn't cancel? Minutes. And what unit do you want your answer in? Okay, that's how you know you're done. So when your final unit matches what you're looking for, you're done. How we're going to solve this problem is you're going to multiply the top row. So what's 2.5 times 60?
150.
Thank you. The bottom row is going to be really easy on this one. We would multiply the bottom row. So what's 1 times 1? Okay. And then we would just divide them. So 150 divided by 1 is? Okay. And what's our unit? Okay. Okay, last step will always be rounding to the correct number of sig figs. Okay, so when we do dimensional analysis, we multiplied. Okay, so if we multiply, are we looking at sig figs or decimals? Sig figs. How many sig figs are in 2.5? 2. 1 hour is equal to 60 minutes. That's one of our definitions, so it's an exception. Okay, so do we count these for sig figs? No. Okay, so if we started out with 2, how many does your answer have to have? 2, and how many do we have? 2, so we're good. All right, so for our next one, we're going to figure out how many seconds are in 2 days. So before we just start calculating, we need to make some sort of a plan or understand how are we going to convert all the way from days to seconds. Okay. So I like to just make a game plan. So we're going to start with days because that's the number given. Okay. Do we know how many seconds are in a day?
No.
Okay. What do we know though?
Hours.
Okay, so we know how many hours are in a day. So we can go from days to hours. Do we know how many seconds are in an hour?
Yes.
Some of us do. Let's say we don't. What do you know though?
Minutes.
Okay, can we go minutes? And then, do we know how many seconds are in a minute?
Yeah.
Okay. Okay, so before you start that dimensional analysis, make sure you have that game plan. So make sure you know how are you going to get from one unit to the next. It doesn't have to be any fancier than this. Okay. So then now once we have our game plan, we can actually do the dimensional analysis. So I'm a box person. I draw the boxes. How do you know which number you're going to start with? Okay. It's the only one given. Okay, so you're going to start with 2 and your unit is days. Okay, so you're starting with 2 days. If you don't like an empty box, what are you going to put in the bottom box? Okay, a 1. That's me. I don't like empty boxes, so you'll notice I'll always put a 1 down there. All right, now we're just going to follow our plan. How do we get from days to hours? How many hours are in a day? Okay, so 24 hours in a day. If the unit day is up top, what unit has to go down here? It's got to be days. It has to match. Okay. So we'll write 1 day on the bottom. And then remember that number up top has to be equivalent. So 24 hours up top. Okay. And then the reason why day has to go on the bottom, take a look. They cancel. Okay. So remember at this point, the name of the game is just how do you cancel your units. Okay. Now we can go one step further. We have to get from hours to minutes. What's the relationship between hours and minutes? How many minutes are in an hour? Good, 60. So then the way you decide which number goes where is you look at this unit. So if hours is up top, what unit has to go down here? Okay, it's got to be 1 hour. And then what unit has to go up top? 60 minutes. Okay. And so again, cross off your hours. Okay, so physically cross them off just so it helps you remember why it matters where your units go. All right, and then finally, minutes to seconds. What's the relationship? 1 minute is? Okay, 60 seconds. If the unit minute is right here, what unit has to go down here? Okay. And what number are you going to write with it? Okay, so it's going to be 1 minute is equivalent to 60 seconds. Okay, so then how you know you're done? If you physically cross out your units, you'll eventually get to where 1 unit doesn't cross out. Okay, so I'm in seconds, and does that match my final unit? Okay, so once you're in that, so like my dimensional analysis, my only unit that didn't cancel matches my final unit, that's how I know I'm done. So now you're just going to multiply this entire top row. So 2 times 24 times 60 times 60. Once you have a number, someone say it out for me. It should be large.
100.
172,800. Okay. If we had numbers on the bottom row, we would multiply the entire bottom row. Okay, but what's 1 times 1 times 1 times 1? It's 1. Okay. I am going to show you how you would calculate it. So you just multiply the bottom row and then divide. In this case, which number are you going to end up with anyway? Okay. Same thing. And what's your unit? Okay, seconds. Okay, this time we're looking at how many cups are in 120 teaspoons. And I would not expect you to know this conversion off the top of your head, so I give it to you. There's 48 teaspoons in a cup. Okay. So with this conversion, can we go directly from teaspoons to cups? Okay, so if we want to write our game plan, we're just going to go from teaspoon to cups. All right, what number are you going to start with? Okay, you're going to start the 120. You are always going to start with the number in the actual word problem. Okay, so we're going to start with 120 teaspoons. And then there's 48 teaspoons for every 1 cup. Okay. How do you know which number to put where in your next set of boxes? Okay, we care about making the teaspoons match. So if teaspoon is up top here, what unit has to go down here? Okay, teaspoons. And how many teaspoons? Good. All right, so 48 teaspoons in the bottom, 1 cup in the top. So teaspoons cancel. How do you know that you're finished and you're ready to calculate? How do you know when it's done, though? Okay, when your units match, right? When this unit didn't cancel and it matches the unit I want my answer in. Okay, this time, what's 120 times 1? Okay, then we multiply the bottom row. What's 1 times 48? Okay, now you just divide. So what's 120 divided by 48? 2.5? Okay. And what's your unit? Good. Cups. Last step is to count sig figs. How many sig figs are in 120? 2. 48 teaspoons in a cup. Honestly, I'm not like a baker, so I don't know if that's an exact, I don't know if that's a definition or a measurement, but even if it were a measurement, how many sig figs would there be? 2. So how many should your answer have? 2. So we'll leave our answer at 2.5 cups. Okay, this time you have $7.25 in your pocket in quarters. Okay, how many quarters do you actually have? Do you think you're ready to try this one on your own? Yes. Okay, I know a lot of you can do the mental math, but I want to see dimensional analysis. Okay, what conversion factor do you know between dollars and quarters? Okay, there's 4 quarters in every dollar, right? Okay, what number did you start with? Okay, so $7.25 is what we started with. Okay, what number did you have to put on the bottom of the next box? Okay, $1. What one on the top? Okay, so dollars canceled, you're in quarters. What is 725 times 4? Good. 29 quarters. Okay. I see mixed answers for sig figs. In this one, it's kind of a silly sig fig. If you take 725 as an exact number, do you have to count sig figs? No, if you have exactly 7.25, it's exact. You don't have to count it. Some of you counted this for 3 sig figs. So how many sig figs would your answer have to have? So what would you write? Okay. Either of these are fine for this one. Okay. Okay, how many seconds are in 1.4 days? We're going to write our answer in scientific notation. Okay, so again, before you just start, make that game plan. Do we know how many seconds are in a day? Probably not, but what do you know? Okay, we know how many hours are in the day. Okay. Do you know how many seconds are in an hour? Okay, some of you do. This time I'm going to just go straight to seconds. If you don't know, could you go to minutes, then seconds?
Yeah.
Sure. Will we get the same answer? Yes. Okay, so we're going to go from days to hours to seconds. Okay. So what number are you going to start with? Okay, so we're going to start with 1.4 days. Okay. What goes in the next bottom box? Okay, 1 day. What goes in that top box? Okay. So days cancel, we're in hours. What goes in the next box? Let's do the bottom box. Okay, 1 hour. How many seconds are in an hour? Good. Okay, 3,600 seconds in an hour. Okay, how do I know I'm done? Like, how do I know I don't need another box? This is important, especially later on in the year. So how do you know when you're finally done? Good. Okay, when this unit matches this unit, right? Then we're done. And then go ahead and just multiply across. So what's 1.4 times 24 times 3,600? It is going to be a big number. So you can just like read me numbers if you want. Okay, hold on. 120. Okay, do y'all agree with that number? Okay, and then big numbers. We don't want really large numbers, so we want to convert them to scientific notation. Okay. How many sig figs are in 1.4? 2. Okay. Days to hours definition, hours to seconds definition. So do those count? Okay. So just 2 sig figs in your answer. So that's where the 2 is. And remember, we look to that next digit. We're going to round it up or down? Down. Okay. So this number, it rounds down to 120,000. And then we're going to convert it to scientific notation. So when we convert to scientific notation, we want to put the decimal in between those first like non-zero digits. So in between the 1 and the 2. So we just have to count how many places do you move the decimal. Okay, so if you count, we moved it 5 places. Okay. So then when we write it in scientific notation, it becomes 1.2 times 10 to the 5th, and our unit is seconds. Okay, what are we noticing? Where's the mistake in this one? Okay. I think y'all are talking about this one, right? Okay. What do you need to do with this one? Flip them. Right. Okay. Because does a day and a day, if you multiply them, do they cancel? No. Okay. So you need to flip that one. Okay. One last one. One more together. Okay. So let's say I drive 5.8 miles to school each morning. How many inches is that? And then how many centimeters is that? We'll express our answers in scientific notation because are we expecting large or small numbers? Like really large. So we'll go to scientific notation. There's 2.54 centimeters in an inch. Okay. So how many calculations are we doing? How many different answers are you solving for? 2. So we're going to do 2 different calculations. We're going to do one where we solve for inches and one where we solve for centimeters. Okay. Either way, what unit are you going to start with? Okay, we're going to start with miles because that's the number given to you. Okay. And let's just solve for inches first because it's listed first. Oops, I meant to go red. Okay. Do we know how many inches are in a mile? Okay. What do we know, though? How many? So do we know how many feet are in a mile? Yes, we know how many feet are in a mile, right? Do we know how many feet are in a mile? Okay. Do you know how many inches are in a foot? Yes. Okay. So this step is important, right? If you don't have your game plan, do you have any hope of like magically getting numbers right in your dimensional analysis? Okay. So you have to have your game plan first. So can we go from miles to feet to inches? Good. Okay. How many miles are we going to start with? Yep. Yep. We're summing for two different things, so we'll do two different calculations. Okay, so we're starting with 5.80 miles. And we have to get from miles to feet. Who knows how many feet are in a mile? Good. 5280. Does that sound familiar? Is there some significance to that number very nearby? Not at all. Doesn't ring a bell? Okay, what unit has to go on the bottom? Okay, miles. Okay, so for every 1 mile, how many feet are there? Okay, 5280. So miles cancel, we're in feet. How many inches are in a foot? Okay, where does the 12 inches have to go? Okay, 12 inches has to go on top. Why? Okay, 1 foot has to go on the bottom to cancel that unit. All right, so now how are you going to put this in your calculator? Okay, multiply 5.80 times 5280 times 12. Does anyone have an answer? 367 488. Is that it? Okay, thank you. That's good. Do I have it right? Or am I missing one? We're good. So 367,488? Okay. Sig figs, how many are in 5.80?
No, you missed one. It's 3 million.
Are you getting 3 million or 300,000 something? Okay. Is majority getting 300,000? Okay. How many sig figs are in 5.80? 3. Okay. How many would be in 5280? Still 3. This one isn't exact, so we're not going to count it. So how many should your answer be in? Okay. So that's where the 7 is. Is that 4 going to cause you to round up or down? Down. So when we say down, it just means it rounds down to 367,000. All right, and then how would you put this in scientific notation? Good. Okay, do we agree with 3.67 times 10 to the 5 inches? Okay, what's part 2 of this problem? Okay, part 2 is to convert from to centimeters. Can we go just from inches to centimeters? Okay, so for part 2, we're just going to go from inches to centimeters. Okay, when you use your inches number, take your unrounded number. Okay, we really don't want to round until the very end. So we're not going to take this number because this one's already rounded pretty heavily, correct? Okay, so you're going to take this number. Yep. So we'll start with 367,488 inches. All right, and then if you use the conversion factor I gave you, how many centimeters are in an inch?
2.54.
Okay. So 1 inch is equal to 2.54 centimeters. Okay, so now go ahead and just multiply those two numbers. Okay. And if someone has an answer, you just say it out loud. Hold on, 933,419.52. Do y'all agree with this answer? Okay. So we don't want to round until the very end. However, how many sig figs was this number good for? It was only good for 3. Okay. And then how many are in 2.54? 3. So how many should be in your answer? 3. Okay. So that's this 3. And is that 4 going to cause you to round up or down?
Yeah.
Okay, down. So this is going to round down to 933,000. Okay, and then we're going to put it in scientific notation. So we just put a decimal at the end. And how many places do you move the decimal to get it in between the first 9 and 3? Yeah, that should be 5. So 9.33 times 10 to the 5th centimeters.